bypassed this test right at start with. There was some confusion and you guys wound up with the wrong test to begin
Ended
with.
up with 2 instead of
Yeah, we ended up with 2 instead of 1, so we're backing up and doing 1. And this right here is some basic stuff, it's basically about how that stuff works. Let's talk about this right here. We've got the atomic structure of an atom, including 3 basic particles, protons, neutrons, and a nucleus.
what happened to electrons.
Yeah, there you go. That was a falsie there. Copper's an excellent conductor. Direct current is used in automotive vehicles.
True.
Incidentally,
That's
you
false.
heard, huh? Yeah, that's true.
Oh, okay.
DC current. What's the difference between DC and AC current?
AC, that's the one you use in the house, right?
Yeah, it is. Why do you use that in the house instead of DC? Of course, you've been using AC in your house for so long, you just didn't ever think about it. You can actually do more with AC current with smaller wires. You know what I mean? If you use DC current, you'd have a lot bigger wires
Yeah.
than you would, I mean, to pull your house current. And Edison, that, you know, he actually was a great fan of DC current, and he thought everything ought to work on DC current when electricity first started getting common. But he had a guy that worked with him named Westinghouse that
The light bulb, man.
had he had a basically, that's what I read somewhere. All right, where you
I
at?
was looking for the staple. I'm sorry, go ahead.
The stapler?
I see it now.
Okay. Voltage, well, is there any place in the car where we use alternating current?
Alternator?
Alternator creates alternating current and is rectified by the diodes, and it becomes about, where do we actually use alternating current as alternating current? You got any ideas?
It's running to the starter.
No.
No.
The starter does not use alternating current.
Okay, let's see. The battery.
No, the battery's direct current. He just taking shots in the dark.
The fuse box.
What about the wheel speed sensors?
Ha, ha, ha.
Or that sensor that you're changing on that crossfire in a minute? It goes, and the reason, if you look at
And I need that too. I need this.
I have got disappearing markers up here. I don't understand what's going on with my markers. It should be not
I
here.
got some at the house if you want them.
I've got plenty of markers I can get from the supply closet up there, but I ought not to have them disappearing off my tray up here. All right, see this? Okay, whenever you got it going above and below 0, that's alternating current. When you got it only on one side of 0, that's direct current, or this would be direct current too. Now on your meter, what is the symbol, when you're looking at your meter, what does the symbol look like next to the,
Alrighty.
yeah, like if you've got alternating current, it's gonna do like that. If it'll say volts, it's gonna have a thing kind of like that right there, a little wave. But if you've got direct current,
Yeah.
you're gonna see something that looks like this.
Yep.
See that?
Okay.
That's basically what you're gonna see on there. So anytime you see a wavy symbol next to that V, okay, what does it mean if I've got this?
That's a 4?
No, that's an A, I'm sorry. I didn't
That's-
write it. Yeah.
Amps alternating.
That's amps. I mean, if you see A, that's amps. If you see V, it's volts, right? Okay, so anyway, just remember that. It's pretty straightforward. All right, now, voltage is equal to current divided by resistance.
False.
No, that's true.
That's right, Willie. Remember this? E, I, R. This right here is resistance. This right here is volts, and this right here is amps. So if you take that, are you wrong, Willie? Am I wrong and you wrong too? Did we mess up?
Voltage is equal to the current divided by the resistance. Are we wrong?
We wrong.
I didn't think it was
Actually,
right.
yeah, see, Melissa was right, but you're gonna take this and multiply them to get that.
Y'all
You
had me
don't
confused.
divide. You
No,
multiply.
I was
voltage
about
is
to look
equal
it
to
up. Y'all had
current
me
times.
confused.
And if you multiply this times this, you get watts.
Okay.
So you can figure out what the wattage on a bulb is by finding your power source, how much is there, 12.5, whatever. And then you're gonna find how many amps that thing's pulling by hooking your meter up. And you multiply volts times amps on the readings you get, you can figure out how many watts that bulb is. Ain't that pretty cool? All right.
I was sure about to look that up when you said that
I
was
did the
true.
next one true.
Yeah. Me and Willie were just, me and Willie knew the answer. We were just jerking all around with it, really. So.
Yeah, okay.
Isn't it something how you can get words crossed up in your head and just say something totally stupid and wrong, and then later, if you were talking to somebody that didn't know the difference, you're thinking, oh no, I gave them bad information, you know? And they're gonna find out I was an idiot. Okay. Resistance is the opposition to current flow.
True.
That's true. Logic probes are sometimes called electronic circuit testers.
True.
What the heck is a logic
I
probe?
don't know.
Do we have one?
We do.
I imagine you do. And then, the test light meters and all.
Yeah, that
wouldn't all
ground
be-
lights are.
No, a logic probe is actually the one you hook up to power and ground. And when you touch the hot side of the battery, it turns red. When you touch the negative side, it turns green.
Aha, I've seen
Oh,
that
you talking about
before.
that? It's like a test light, got different colors in it?
Yes,
Yeah.
that is awesome.
Yeah,
Yeah.
that's right. But you're
Adam
hooking it up
had
to
one.
Adam likes to
Yeah.
fool with them logic probes. But the only problem with those is they're not measuring current flow. I mean, they're not measuring available current. They're only measuring available voltage. And I ran into a problem one time years ago, and I talk about occasionally because it illustrates what I'm talking about. I was taking the Ford service manual and I was working on an ABS system that had an anti-lock brake light on. And there's a relay in there that actually, the relay is wired up on that particular car, you know, where you've got your common and you got your normally closed, your normally open. This is your coil. And this right here was B plus, which, well, let's do this way. This was B plus, and this right here was ground. So this right here, when that relay was at rest, this was grounded. And whenever you energized it, this was powered up, and it was part of the ABS system. And so what I was supposed to do was energize, with that relay energized when the key's on, I was supposed to check right here, and according to the shop manual, I was supposed to have greater than 10.5 volts. That was Ford's trouble matrix, you know. Like whenever you're looking, you're not real familiar with the system, you try to follow the troubleshooting tree, and that's what I was doing. On that one, I wasn't all that familiar with that particular system at that time. Well, I got like 10.8, and what is your mind telling you? It says I'm supposed to have greater than 10.5, so I've got 10.8,
Exactly.
and I kept on moving. And I went all the way to the end of that trouble tree, and it told me to replace something or do something that was not, it didn't fix it. I can't remember what it was. And I said, I have lost something. I lost my way somewhere. I've gone off the straight and narrow, and I'm stumbling down the broad path to not be fixing the car. All right. So I says, I need to go back here, and I need to, when I looked at this schematic and I figured out that this needed to be pulling a load, you know, there needed to be enough juice coming out of here to actually make things happen. Components were energized by this relay. I took my test light and connected it, and when I hooked the test light up to it, it wouldn't even burn the dadgum test light. But that meter was telling me there was 10.5 volts there. That's because this right here, whenever I turned on the key and this clicked over here to the hot side, these contacts were so filthy that voltage would go through them, but you didn't have any current. I can take this meter and hold one side of it, let you ground the other one on the battery, and then I can lick my fingers and touch the positive side of the battery, and you'll see that meter show 10.5 volts or 11 going through my body, but it won't burn a light. That's what a current limiting resistor is coming out of the engine controller. If you've got an engine controller and it's putting out a 12 volt signal, and some of them do for AC, and and you've got switches that you see that shorts that 12 volt signal to ground, you'd think, well, that's going to blow a fuse or burn something up. But if you have a current limiting resistor inside the controller, all it does is make that 12 volts go away. You got me? All right, now think about this. The reason I'm saying this is if I don't say it, I'll forget it. And besides, this is interesting stuff, and I enjoy telling you all this. All right, now we've talked about this a little bit before. This right here is your stoplight bulb. We're just going to make it real simple. We're going to make this come up here, we're going to come down here, and we're going to go there, right?
Okay.
Okay, we've got a stoplight switch. We've got a fuse. We've got B plus. Right there, is that good? All right, now then, this switch right here, when it's open, all right, my cruise control is looking at that brake. And what is it seeing there? What is that cruise control module seeing there on that line when you don't have the brake pressed?
It means that the brake is not pressed. There's
Like,
no-
I know, but how will it know when you press the brake? What's it looking at?
Whenever it closes.
It doesn't care a rip about voltage. It ain't looking at voltage. Not on that.
It's looking to see if that switch is closed.
It's looking to see if that's got a, if that ground is coming through that filament into there. If you've got a cruise control,
So you're
that's-
saying that switch don't make any difference?
that switch makes a difference, but what happens to this ground when you close that switch?
It just
Goes
comes-
away.
Yeah.
It's no longer a ground.
Hey, there goes the Mickey.
Yeah, there go that home girl. Let's see here. That look like a right one?
Yeah.
That's a crank thing.
I know, we're gonna have to replace it again because they sent some second-rate Chinese-made junk before and it didn't, and we can't trust it. She hasn't pulled the old one out, but it'll be ready for you.
Okay.
All right.
Well, can I ask you a question? How could it be the crank sensor if the car cranking up when you jump?
When I jump what?
What is that for?
No, what happened was, when we got ready to start it a while ago,
It was cooled down.
it would go and it was not starting. Didn't you hear that? We got a scan tool, we put it on there, and it said, no crank sensor. Now, we know our first crank sensor was bad. Melissa, how did we know the first crank sensor was bad?
Because when you heated it up, it lost power at a certain degree.
We actually put a ohm meter on it, set it on the 20,000 ohm scale, and it was reading 1,050 ohms. And we heated it a little bit with the heat gun. We didn't have to heat it much. I had a heat gun on it at a distance of about 3 or 4 inches away, and I heated it for something like 20 seconds, and it opened up. So we know that sensor's bad. That's non-negotiable. We put another sensor in there that we bought from the parts shop. We don't know who made it or where it come from or what the quality of it is. Put it in there, fired it up. It run for a long time. It never quit. But then we go to crank it up and back it out of here, and we got no crank signal. We just replaced that sensor. The wiring harness is not damaged or anything. We don't have anything left except the
Replace the crank.
the sensor itself. So I told them, since we just replaced that, let's throw another one at it. We're gonna make darn sure she ain't sitting beside the road somewhere between here and wherever she lives.
Yeah.
You know, that just ticks me
Are
off.
they just gonna give you this one?
Well, we're gonna take the other one and put it in the box, and they're gonna defect it out and send it back to the manufacturer. Anyway, but what I was getting at is, this becomes the current limiting resistor. Because whenever you hit this pedal here, so you're reading ground right here. You hit this pedal here, it doesn't care if there's power here or not, it just knows that that ground went away. Now, how do we know that that's what it's thinking about? The way we know that's what it's thinking about is if I had one I wanted to get you guys to troubleshoot, I could come along and put a couple of blown bulbs in there and the cruise wouldn't work
That was the ground, bro.
because it ain't seeing the ground. Now, one blown bulb won't do it, 2 has to be blown. You know, it has to have no ground at all. And I ran into a Ford Focus one time that was the guy that was working over there. As a matter of fact, it's the guy that hired, he's a service manager over at Nissan now, and he hired Daniel Kelly. And anyway, so Daniel, he was over and he said, I can't figure out why this cruise won't work. You know, he says, I've already checked all of these voltages and I've already replaced this, that, and the other and all that. And I said, well, let's just get our test light and let's look at the hot. And let's take our test light and touch it to the wire that's coming from the brake lights. You know, it's redundant. They got other things going on, but that's one of the things that can keep it from, can cancel the cruise. And so I checked it and we had a very dim glow coming from that bulb. And I said, now there's another Focus over here just like this one. And so we back probed that one with a little, straight pin, and we touched that one and it was bright. I said, what's the difference between these two? The one that the cruise don't work on has got a dim light. The one it does work on has got a bright light where the brake feed goes into the cruise module. And he said, I don't know. And I said, walk around the back of the car and let's just have a look at it. And somebody had put them smart LED tail lights on it.
Oh, no.
You know, the fancy ones.
The ones that-
And they didn't provide enough of a ground for the cruise control to work. He said, well, what can we do about that? And I says, buddy boy, there's several things that you don't modify. One of them is airbag.
One
One of them is cruise control. You know what I'm saying? And one of them is ABS brakes. You don't fool with them three things as far as modifying them and trying to do something on your own to make them work right. The only thing we can do is put the lights back on this thing that started on there. There might be a way you can make it work if you added some lights and all, but what if the crews don't cancel and they run under there and knock a car off the lift or something like that? You know what I'm saying? I mean, we got to make darn sure that we don't make a modification, you know. If you make a modification that causes somebody else to have an accident, you know, it's just real easy to shrug your shoulders and walk away and say, oh, well, you know, ain't on me, you know. But I mean, the thing about it is that you got to be more responsible than that. So you don't modify supplemental restraints, ABS brakes, or, you know, I'm talking about electrical stuff now, or cruise control. You leave it like it was made. Don't tinker with that, because if something happens, it's on you and the shop you work at and the horse you rode in on. All right. Now then, let's look at a positive lead, test lead on a multimeter is usually black. Oh, that's absolutely false. It's common for a circuit to have both series and parallel connections in the same circuit.
False.
Actually, it is true. Can you think of a way? Can you think of a place?
It's coming for a circuit of both series and that's gonna be.
If your switch is in series with a parallel circuit, you got it like this, or you got a series parallel circuit, you know? You know what I mean?
I'm hungry, that's nice.
He'd be hungry. You know, it's 6 minutes. All right, let's see here. Short circuit occurs when two conductors touch each other where no connection is intended. Yeah, you call that a short circuit because it's, you know, going somewhere it's not supposed to go and finding its way back sooner than it should. Plastic, rubber, and glass are three materials commonly used as resistors in motor vehicles. That's not resistors, that's insulators. What's the resistance if the voltage is 12 and the current is 2 amps?
Good question.
Huh?
That's a good question.
What's 12 divided by 2?
6.
6. So that's going to be what?
6.
B, 6 ohm. Diodes, Zener diodes, light emitting diodes, transistors, and thermistors are what? A, devices that are used to read a vehicle's trouble codes. B, devices used to protect vehicle electrical systems. C, devices that all display voltage changes within a certain time period. Or D, solid state devices made by using combinations of the basic p-n junction.
B?
That's D. A Zener diode is a diode that will it will allow current to flow both ways when a certain voltage threshold is reached. That's the difference between a regular diode and a Zener diode. To prevent voltage spikes, a blank is commonly used. A clamping diode. A clamping diode. I need to explain that too while we're here. I've got an AC compressor clutch here. And it's got lots and lots and lots and lots of windings in here. And right here, I've basically got ground. And this right here is coming from a relay right here, right? And this right here is going to the PCM. If the PCM tells the relay to open up, right? And the relay opens up, whenever you have all that magnetism sweeping across that coil, it collapses that field. What does that remind you of? An ignition coil. What does an ignition coil do? It makes a dadgum spark. It will knock you on your fanny. This right here will send a 400 volt spike screaming right into the heart of that PCM. Unless there is a diode in there. See there? You put a diode right there. That little diode, you'll put a little diode right there. And that's called a clamping diode. And every air conditioner compressor clutch has got one of those. Now, it's not built into the clutch, it's in the wire harness. You know what I mean? That has to be there. If somebody ever puts one on there and they don't put that in there, it's going to fry something. I ran into a Devil Cablevision truck one time that was brand new, and it kept eating radios. I'm talking about just a plain old AM, FM radio. It kept eating them. I mean, to destroy them. And so I found out they had an AC style compressor clutch driving a PTO for the hydraulics for the bucket, and they didn't put a clamping diode in it. And if you happen to have everything turned on, when you click that thing off, that voltage spike would go screaming back into that wire harness, and it would find its way up into that radio and just punch it in the teeth, and that radio could take a few of them, but it couldn't take very many, and after a while, it was dead meat. So I put a clamping diode in it, just like these little diodes I got in here, and you're good to go. All right, let me see here. According to Ohm's law, what? E equal IXR? See,
All of the above.
yeah, all of the above. That's 14, that's D. Voltometers, test lights, scan testers, oscilloscopes are used to test what?
B and D. B and D.
B and D. All right. An electrochemical device that supplies current to the starter and ignition system and to vehicle electrical systems when the generator cannot handle the load
Can I
is
ask you
called
something
a,
real fast? Can I ask you something real fast? Where does D make sense that it's both B and D on 15?
well, electrical circuits and solid state components.
That's B and C. D says B and D.
What now?
She's saying
B
there's
and
no
D.
D, there's B and C.
Oh, I see where you're going. That's a screwed up question. Should have been B and C. Yeah, I did not write that question, so don't give me a hard time. I mean, if I did write the question, I deserve a hard time. Come on. All right, that's the end of that test. What do you think about that?
No,
Wait, what was 16?
Oh, we got this right here.
you got some, well, we didn't finish 16.
Hold
yet.
on, let me see what this phone call is. Hello?
Hello, Mr. McChristy.
Yeah,
Kristen, sorry. This is Ted Marsh. You're working on my expedition. I just wanted to call and see how everything was going.
that's on the heat.
The what?
Oh, no, I'm sorry, we got two different expeditions in here and I got screwed up. Yeah, we got the new transmission came in today. We had a little hiatus because of the cold and the college was closed. And, he should have the, old transmission out today. The new one's sitting here on the floor. We're gonna get ready to stick it back in there.
You can put that transmission in.
Okay, so you think by this week sometime?
Hopefully, don't come before I call you because it may not be through this week, but if it is, I'll give you a call. We got a good chance of it.
Thank
Okay,
you very much.
All right.
Just wanted to see where you guys were at with it.
no problem.
Have you any other problems you guys running into?
Not that I know of, I mean, not on that vehicle.
Okay, well good. That's good news.
All right,
All right, well thank you very much.
sure enough. Okay, number 7, I'll tell you what, these matching things, any material that contains free electrons and either allows the flow of electric current is what?
We didn't do 16 yet.
What? We didn't do 15?
16.
We did 16?
No.
I thought we did.
No, I stopped you because
Didn't I
of
read?
14.
She stopped me to
Oh,
tell you about
well, 16, what is that? If it's an electrochemical device that supplies current to the starter and ignition system and vehicle electrical systems when the generator can't handle load is called what?
Circuit breaker.
Huh?
The only thing that can fly.
That's a battery.
Battery.
Come on. You guys are working on batteries, aren't you?
Yeah.
Okay, number 17.
Any battery is there.
17 is what? That's a conductor, isn't it? The movement of electrical energy through a conductor. What's that?
Is
What'd you say, Alex?
8.
H is good. That's right, Alex. Oh boy. Any material that lacks free electrons?
8.
That's going to be A, isn't it? The measurement of the pressure that causes electrical energy to flow?
B.
That's going to be B. Listen to Alex. Boy, he's going to town, ain't he? The device that converts mechanical energy to electrical energy.
C.
Charlie, that's right. A short length of insulated wire designed to melt when current flow exceeds the rating for the circuit.
E.
That is a fusible link. Yeah.
What you came out?
It's got hypolonic insulation on it, and it burns in two. And you know, the ones on Ford cars are a kind of a silver colored wire, but sometimes they'll sell you one that's got copper wire. I don't understand it. Number 23,
G.
a schematic. What's a schematic?
G.
Wiring diagram. A test instrument that can measure voltage, current, and resistance.
Ooh, that's an F.
A test instrument that checks for a complete current path.
Ah.
You guys are doing well. Can't get anything past y'all. Okay, now, some of these worksheets right here are so swift. Guys, as quick as you can get these knocked out and turned in, the better off you'll be, because some of these are pretty swift.
I had mine already did.
But,
Your test.
Yeah.
yeah, he did his, he made 100 on it.
Look, I ain't had time to